Okay, Chapter 6, Section 1, Simple and Compound Interest. In this section, I'm going to talk about two different kinds of interest, one which is relatively unrealistic, and the other one, which is the one that you're most likely to encounter if you invest or if you have debt, credit card debt, student loan debt, car loans, cell phones, etc. Okay. Simple interest is the kind of interest that you would get from a family member who adored you. It is not the kind of interest that you're going to see very often in real life. But it's a good starting point to get us to thinking about the time value of money. Because money, when it's used correctly and not just stuffed under a mattress or in a jar somewhere, will change value over time. Now, in economics and in other finance classes, you'll talk about, if you take those classes, you'll talk about inflation and all that kind of other stuff. We're going very, very basic here. We're not going to incorporate anything other than how much money you started with, or how much you owed from the beginning, what your interest rate is, and how long you plan to have that particular instrument, whether it's a loan or an investment. So, simple interest has these components. You have a principal, and principal is the amount of money that you either borrow at the very beginning, charge to a credit card, take out as a student loan, or that you invest or give to someone else as a loan. It's the initial amount of money associated with a particular investment, loan, instrument. Okay. Often we use the letter P, capital letter P, for principal. Sometimes, though, it's going to be more useful to refer to that as PV, which stands for present value. How much it's worth right now. Okay. For the purposes of simple interest, I'm going to stick just with the letter P. The other thing you need to know is your annual interest rate. Now, your annual interest rate is going to determine, well, what that money is worth to someone else. If you borrow money, you've taken away someone's opportunity to use that money. So you're going to owe them more money than what you borrowed because they lost an opportunity to use the money that they had because they gave it to you. On the other hand, if you loan money or you put money into an investment or you put money into a savings account, then you're giving that money to someone else. And when you give that money to someone else, even if you have access to it, you give that money to someone else, then you've lost the opportunity to spend that money at that moment. Okay? So there has to be some sort of value associated with that lost opportunity. Economists will call it opportunity cost. Okay? Now, annual interest rate for simple interest problems is going to need to be first as a percent, but then to convert it to a decimal. Okay. And then finally, number of years. Number of years may be how long you agreed to wait to pay back the money. It may be how long you agreed to give the money away to someone else before they pay you back. But it's the life of the loan or the investment. Okay. Now, I forgot to say what letter of the alphabet I'm going to use for annual interest rate. For the purposes of simple interest calculations, I'm going to use the lowercase letter r. For the purpose of the simple interest for number of years, I'm going to use the letter T, lowercase letter t. So, how much we borrowed or loaned out or invested, it's a big P. Interest rate as a decimal, little r for rate, and number of years, little t, for time. Simple interest is unusual in that with simple interest, is only charged based on principal not anything else. Now, what do I mean by anything else? All right, so when you borrow money for a car, you make payments on the car. So every month, the amount you owe goes down because you're making payments. That's a different scenario. Here, in simple interest, the formula and the process only cares about what you initially borrowed or what you initially invested. And so, this is the least advantageous kind of interest for anyone who wants to make money. It's the most advantageous for anyone who wants to borrow money. But it's not going to be the kind of interest you're going to find in the real world. Like I said, someone who loves you very much may give you a simple interest loan. Someone you love very much, you might be willing to give them a simple interest loan. A bank ain't going to give you a simple interest loan. One thing I want to say before I go too far. You will hear often in the finance industry people say simple interest on the unpaid balance. Now, when I say simple interest, you don't hear me saying any other words, no prepositional phrases after that. Simple interest. Period. Okay? When you hear someone say simple interest on unpaid balance, they're doing a word game with you. It's not unethical, but it's a word game with you, and it's something very different than what we're about to do. Okay? So, we're going to be very Amerocentric, and we're going to use dollars for our principal values. Rate, you need to be able to convert a decimal to a percent. So, for example, 10% is 0.10, 12%, 0.12, 5%, 0.05. You drop the percent, divide by 100. So make sure that whenever you're using the formula I'm about to put up here on the board, that you drop the percent, divide by 100, convert the percent to a decimal when you're looking at the interest rate, or the formula is going to be really off. Number of years, 1 year, 1, 2 years, 2. Just keep in mind that if I say 6 months, that's half a year. Time in this formula is always going to be measured in years. Years, 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 years. Okay? So if I say 1 month, that's 1/12 of a year. If I say 6 months, that's 1/2 of a year. If I say 5.5 years, then T would be 5.5. Now I'm going to pause. If you need to rewind, replay, or whatever, this is an opportunity for you to do so. So what happens to your money? You put in some principal, and then you get interest. I'm going to use the letter big I for interest. So again, this is principal, and this is interest. And over time, that account will accumulate value. Now, how do we compute the interest? When we're dealing with only simple interest, which I am in this particular video, simple interest only depends on how much you initially invested or loaned, borrowed, the interest rate as a decimal, and the amount of time that that loan or investment exists. Also, important, we're not going to be adding any more money to this account. We're not going to be borrowing any more money. We're not going to be loaning out any more money. And we're not going to be taking any money out. Okay? There's no in and out. Other than money goes in at the beginning, and at the end, it goes to wherever it's supposed to go. Okay, so, since interest depends, in the simple interest case, only on the amount of time and the interest rate, the interest is your original principal times the interest rate as a decimal times the number of years. This is an annual interest rate as a decimal. T is the number of years, maybe even as a decimal or a fraction. So this is sometimes referred to with the big letter A, which can represent the word amount, or can represent the word accumulation, or amount accumulated. Either one of those words starts with a big A. Finance people are going to use different letters. We'll do that later. Now I want you to focus on this equation. The amount accumulated in a simple interest loan or investment is the initial principal plus the interest. And the interest is principal times rate times time. Now, sometimes I use asterisks for my multiplication, and sometimes I use dots for my multiplication. Depends on my mood. Now, I can take that formula and rewrite it so that it's easier to pop into a calculator. And that only requires a little bit of algebra. Now, when I say a little bit of algebra, I do mean a little bit. I'm going to factor. Now, if you're thinking, no, please don't factor. Guess what? I'm a factor anyway. I keep looking at myself and not at the camera. I got to stop that. Okay. Factoring is dividing. This has got a P. This has got a P. There's two terms. Terms are separated by the plus sign. Factoring is dividing. P divided by P is 1. P times R times T divided by P is R times T. And this is a formula a lot of people like for simple interest, mostly because it's easier to type in. You don't have to type in P twice. You just have to type parentheses instead. All right, time for an example. All right, I'm back. Some people say, Dr. Young, which one of the formulas do you want me to use? Whichever one you like. Okay, they're the same formula. Just depending on what device you're using, maybe your calculator doesn't allow for parentheses, so maybe you would rather use this formula. I often tell students that if you're working by hand and, well, not by hand, but with pencil and paper and a calculator, to write down intermediate steps. So I'm going to show you what I mean with an example. This is example 1 in your book on page 262. Mr. Steiner is going to put $3,000 into a savings account. Aha! P equals 3,000. I wonder what interest rate he's going to get. It pays 5% simple interest. Simple interest. Now, many of you might be tempted to just write 5% and walk away. Don't do that. You got to convert it to a decimal. Drop the percent, divide by 100. R is 0.05. And according to this example, Mr. Steiner's only going to leave the money in there for 1 year. Since T measures time in years, T is equal to 1. All right, so there's 2 ways I can approach this problem. Actually, there's more than 2 ways, but I have 2 formulas. I want to find out how much money Mr. Steiner is going to have at the end of 1 year. I can go ahead and say 3,000 plus 3,000 times 0.05 times 1, if I'm going to use that longer formula where the P is in there twice. Okay. Now, if I decide to do that, I want to do this arithmetic first. Don't forget your order of operations. Multiplication comes first. 3,000 times 0.05 times 1. You can pop that into a calculator and find out that that's 150. $3,000 plus 150. How much money does Mr. Steiner have at the end of 1 year? $3,150. How much interest did he earn? Well, he started out with $3,000 and he earned $150 in interest. Didn't do anything except for pop some money into an account and walk away for a year, and voila, there was $150 extra at the end. Things aren't going to be that much different if I use the other formula. I'll get exactly the same answer. I'm just going to be using the formula that has been factored. Oh, I wasn't in the screen. Now I am. Okay, so if I disappear, forgive me. How much is accumulated? Well, there's the 3,000 principal times 1 plus the interest rate as a decimal times the number of years, which is 1. It may be really hard to see. Times 1. That may be easier to see, huh? All right. Order of operations. Remember, please excuse my dear Aunt Sally. We don't have much opportunity to excuse anyone, but we will please means parentheses. All right, so I'm going to work inside the parentheses first. Order of operations tells us to do multiplication next. 0.05 times 1 is 0.05. You see how I'm taking this in small steps? Even if you're whipping out a calculator to do this arithmetic, if you feel the need to multiply 0.05 by 1 to find out that it's just 0.05, then fine. One plus 0.05, of course, is 1.05. And now you whip out your calculator and do the multiplying, or you just do the multiplying yourself. And you get 3,150. Again, he's earned $150 in interest because he initially invested $3,000. the end, he had 3,150. Okay, so that's simple interest. There's a couple of exercises I want you to do. And after you've done those, we'll come back with a different video on compound interest, which is what you're most likely to see in real life.